All right. So, like I was saying, when it comes to a mass airflow, one of the things we can always do is do a VE test. The VE test is going to help us determine, is this mass airflow reading actual information, or is this mass airflow skewed? Once we get to mass airflow, I'll talk a little bit more about it. But the VE test is a quick general test for us to determine how is this mass airflow really working, and then we can compare that to our calculated load, wide open throttle acceleration. And if it doesn't go over 90%, then we know for sure that we probably have a breathing problem, right? One of the things that we want to pay attention to is with the VE test, we're going to know, is this a skewed sensor, right? Based off of the VE result and then our fuel trim, or is this a actual mechanical problem that's preventing my engine from actually breathing properly, right? We're going to be able to determine that using that particular VE. So the next thing we're looking at right here, we have an absolute value. This is my Scion. The absolute value is a 10%. So it's saying that the calculated load is 10% on this. Um, Not too shabby for a four cylinder. Okay, so this right here is letting me know that that value should be approximate. Okay, one thing you can do is, I'm not sure if I have it on a later slide, but if you guys go to I have a website. It's called stopthestarprogram.com. And then we have a calculated load calculator that you can actually use to get a value, and then you can determine if it matches within 10% of what your actual car is showing. So again, the website is stopthestarprogram.com. We have a VE calculator on there, Lambda calculator, and we just added this calculated load calculator. So if you guys want to use it, go for it. It's free. It's 100% free. Okay. The next one that we'll be looking at would be Mode 1, PID 5, ECT. So when we're talking about engine coolant temperature sensors, we always want to think about how is it being used and how does it work, right? Not just with engine coolant temp. We want to see this with anything that we're actually looking at. What I was saying earlier is I use this as a go no go check. So I'm using this to determine, um, should I focus on this particular area or not, right? So a typical engine coolant temperature sensor should be reading about 180 to 210 degrees. That's what the engine fully warm. That would be 82 degrees Celsius or 99 degrees Celsius. And or you can always sit there and listen for the cooling fan to cycle. The cooling fan cycles, that's another indication that the vehicle is warmed up, right? And then now you can check that off as a go check, right? So that's why it's called a no go check. Okay, so are we going to go or not, right? So if you're sitting behind the seat with the scan tool in your hand and the scan tool is showing 110 degrees, it's 120 degrees outside, the car's been on for 15 minutes and it shows 110, you got a problem. Okay, so now you're going to be focusing on that cooling temperature issue, right? Whether it's a real temperature control problem or is it just a bad sensor value. Now you have an idea of, okay, I need to go here. All right. Not always will you get a code for that. Why? Unless it falls out of a preset performance parameter, you probably won't get a code. So this is why we need to sit there and look at these values and identify it right away. So we know, are we going to focus our time on that, or are we going to move on to something else? So what I did for you guys here is I have a quick wiring diagram of a thermistor. It doesn't matter if it's an engine coolant temp, intake air temp, fuel temp, transmission temp. It's the same thing. So we got a 12-volt input that goes to a 5-volt regulator. That 5-volt regulator goes to a small resistor, so this way we can reduce the amount of current flow. And then we have a ground circuit that goes to our thermistor. Inside of the thermistor, we have a resistor that changes depending on temperature. So the resistance value is going to change depending on that particular temp. As the temperature changes, the voltage drop is going to be created, and then that is picked up by this sensing voltage circuit. This is all done inside of the PCM. The sensing circuit is going to determine how much that voltage drop is, and then that gives a signal to the PCM. The PCM then knows what the actual temperature would be of that particular thermistor. Okay. So with like anything that we do in the automotive industry, if we understand how the system works, we're going to know how to be able to fix it, right? So this is why I wanted to share this diagram with you guys, so this way you guys can understand how this system is actually operating. So this right here would be what I call my golden nuggets. any class that you guys take, you always want to get those golden nuggets that are going to help you do something easier, better, faster, and more accurately, right? And this is one of them. So the first one here is a P0116, engine coolant temperature circuit range performance problem. Let's take out the coolant temperature and just leave circuit range performance. If I add that circuit range performance to any diagnostic trouble code, what is that telling you? Okay, if you guys have an idea what it is, go ahead and put it in the chat. So whenever you see circuit range performance, what are you automatically thinking evaluation wise, diagnostic wise? What are you thinking when you see circuit range performance? Right? So if you have an idea, go ahead and put it in the chat. And let's take a look, see if anybody puts them. So we have a sensor issue got put up here. All right. What else do you guys think when you see performance? Circuit range performance. Broken wire. Okay. All right. So let's go right back here. Right. And this works for anything. Right. If you guys see circuit range performance, here's what you should think. The PCM has determined the sensor value is outside of expected or present value. That's crazy. So if you see any code, right, ECT, IAT, MAF, MAP, O2 sensor that says circuit range performance, that means the PCM has determined that the value that sensor is giving off is outside of what is expected based off of other sensor values or based off of pre-learned data. Okay, you got to remember, computers are smart. They're remembering certain operating parameters, right? So whenever that falls out of that particular range, that's when we're going to get a circuit range performance code. Okay, so it's telling you that it's outside of a normal operating range, or it's acting outside of what it's used to seeing. Okay, the next one would be a P0117 ECT circuit low input. Forget about ECT coolant temp, just look at circuit low. If I get a car that comes in and it has a circuit low code, okay, what this is telling me is more than likely the PCM is seeing that the bias voltage is getting pulled to 0 volts. So your question should be, what causes a circuit to be pulled to 0 volts? What's going to cause that circuit to get pulled to ground, right? That's what we should start thinking. So then that right there, the only answer would be a grounded circuit. So if I have a car that comes in for a check engine light and I pull the code and it says whatever sensor circuit low, what is the first thing that's going to come to my mind, right? You should be thinking this thing is shorted. So if I'm looking at it on a scan tool, I'll probably see 0 volts. If it's a temperature sensor or a thermistor, maybe negative 40 degrees or 30 degrees Fahrenheit, somewhere around there, right? What can I do to verify that component? Okay, all of you guys should have said go unplug it. If it's showing you a low circuit and I unplug it, right? So we'll say hypothetically this is an engine coolant temperature sensor, and I go and unplug it. Once I unplug it, looking at my scan tool now shows over 300 degrees Fahrenheit. Did that verify that that circuit is actually operational? Okay, if you guys said yes, you're right. By unplugging the sensor, and now my scan tool shows over 300 degrees Fahrenheit, that means the circuit's fine. That means that your short circuit is either in the connector of the sensor or the sensor itself, right? So this is why these little tidbits are super important, because this is going to speed up your diagnosis and your evaluation. With a P0118 ECT temperature circuit high, okay, eliminate ECT and just leave circuit high, right? You should start thinking, what can cause this circuit to go high, right? If I have a sensor that's 2 wires, because this is an ECT, so it has to go to ground. If I'm missing the ground, will I only have 5 volts? Okay, the answer is yes. So missing a ground circuit or open. If I have a high circuit code, right, and I had one not too long ago, it was a Chevy S10, and it got brought in because I had a check engine light. So I pulled the code and it was IAT circuit high. Okay, this is all I had to do. I pulled the hood latch, and I walked around, opened up the hood, and I take a look at the sensor and it was unplugged. Okay, So that right there's all right off the bat, circuit high. I'm missing a ground. It's either unplugged or the ground circuit's damaged, right? And I go check it, it's unplugged. I plugged it back in, cleared the light. Light didn't come back on. Code was gone. And basically just charged the customer for looking at it. It wasn't even a diag at that point. Okay. So whenever you see anything circuit high, always ask yourself, is this missing a ground or is it open? Right? Should I unplug it? Well, you shouldn't because it's already telling you it's open, right? So if you go and plug it, you really can't see a difference. What you can do is you can put a jumper wire, right, in that connector and see how it's affecting the reading on your scan tool. So if you have a circuit high input, expect to see 4.5 to 5 volts. If it's temperature above 300 Fahrenheit, right, and you'll be able to see that on your scan tool. Okay, so these three things are ones that you should know off the top of your head, right? So if you see circuit range performance, that's telling you that it's outside of expected parameter or the value is not where it should be, right? If you see circuit low, what's pulling it to ground? This thing's shorted to ground. Go unplug it and see if the value changes, right? If you have circuit high, it's probably missing the ground or it's unplugged. Okay. So those are three things that if you don't take anything else from today, those three are going to help you guys just become the baddest diagnostic techs out there just by understanding those three.